All right, guys. Now, we were discussing about the missing values in the previous sections. Then we know that how to fill something in the missing data, right? We were using this interpolate method to fill using like, fast, forward fill or backward fill things, right? And in the same way, if you want to fill your own kind of data rather than filling like, forward fill or backward fill, right? Those things. If you want to fill our own data, something like if you want to fill my mean value rather than filling something else, right? How can you fill those values in the missing data? It's more important, to work with this kind of transformation of the data. So what basically we're talking about in a sense, we were talking about how do we transform our data. The transformation is something like you can do anything that is transforming the data to something else. It is not going to reduce your data size. It is simply going to change. It is best for comparisons with other variables. Let's see how we're going to work with. First of all, let me going to import this, import Seaborn library as SNS, right? SNS. And let me also going to use this, NumPy as well, NP. I'm running this cell, right? So let me grab some data, which is you're already aware that is tips data, right? So first of all right, so let me first pick up the data, saying that, say, if I wanted to, so let's say in the tips data, the tips is equals to SNS dot load data set, right? The tips. Then if I'm running this cell, then if I'm saying tips.head, it's going to retrieve it. You already know that if you want to know that tips.shape, you already get to know that this is about 244 and 7 columns that we have it. If you want to familiar with the columns, you can actually check it. This we have total bill, tips, sex, smoker, date, time, size, all these things we have it. The thing is, I don't want to perform all the operations on the, the complete data. Whatever the operations that I'm going to make it right now, I don't want to make it on the complete data. Let me pick it up the random, the 10 data from this data. So how can I pick it up the random 10 data? Only the 10 rows of data I want it. I don't want the complete 244 data from this data. So how can you do that basically in a sense? See, if you wanted to pick up, if you wanted to pull the data randomly, not like, sequence of the data. If you want to pick up that way, we can actually say that here, the dot sample of 10. All right. Then if I'm running back this, if I'm running back this cell, first of all, then if I'm actually saying it right now, and look at this, we got 73, we got 132, right? These are not picked up by me. It is randomly picked. The sample is a method which is going to pick only the 10 rows of data randomly from your tips data, but not sequence-wise data. It is randomly picking up random rows of data. It's well and good. If I'm running back again this cell, then if I'm running back this cell again, you see this again, new difference, 166 and 155, right? Then if I'm running back this again different. So look at this again different. But if you wanted to stick to random, even if it is picking up the random rows of data, if you want to stick to only the 10, and the 10 should be all the time same, then you need to do one more, you need to do one more thing over here. Let me add one more cell over here for you. So I'm saying that np dot random, right? There is a random function within the NumPy library. Then I'm actually seed. Now I'm using seed method. I'm setting it to something else and some number. It's not something that you have to use only the 42. You can use any number, right? But if you set this number, even though if you're picking, even though if you're picking up only the 10 data from this data, the sample data, it's all the time the data will be same data, but it's not regularly like sequence of data. Now let me run this cell first of all. Let me run from first. All right, all right, all right, all right. So we got some data 24th, row data, and 61, 153, 211, 198. Yes. So let me run this cell. Let me run this cell. You got this? Again, the different data. So let me say one moment. All right, you see right now here, I took the seed. That means this is something that it is going to set the seed. So results are deterministic. That means, what does it mean really in sense? See, I'm actually randomly selecting 10 samples from this data tips. Yes. So the random 10 samples would be every time it's going to be changed, even if I run this cell every time. But if you set the seed as 42 or whatever it's so if you run along with this particular sentence, it is going to keep the results as all the time same, even though those are random things, random rows of data from the tips data. So that is the reason I'm taking up this. See, if I'm running this cell, and if I'm running this cell, see, all the time it's same rows of data. It's not changing its, even if you're telling the sample 10 one, see, I'm taking out this head. So we're going to get the 10 data. Let me run this again, and let me run this again. It would be very same all the time, right? See, if I don't set this, what's normally going to happen? If you run this cell for the very first time, it's going to give you the 10 random rows of data. If you run it again, it's going to give you the random 10 data, the different things, right? If you run again, you're going to get the 10 different things, 10 different rows of data. So if you want to stick to one random thing, one randomization, then you have to seed this to this way. Then you run this particular line. Then it's going to give you the all the time, even though those are random rows of data, those are all the time same. So what I'm normally going to do with this data in a sense, let's say now this is this, we know that it's 10 because we only took the 10 data. Then if you want to know the columns, we know I'm not changing the column size anywhere, right? So first of all, see, I'm going to set the random, I mean to say, from this 10 sample data, I'm going to make the total bill, the few values to null. I mean to say few values to the none. How can I make it as intentionally some missing data? How can I do that in a sense? Say, what is the tips, tips data that we have it. So I'm going to say that here, the tips dot lock, right? Lock. So I'm going to use this NP again. So we have something called random, as we already used it. We also have there's permutations, combinations within NumPy itself. So I'm going to use this permutation, right? You'll understand when you see the result. Don't worry about it, right? Then, so that means I'm not willing to make the first four or last four or specifically some rows. I'm leaving it to the, I'm leaving it to the technique that is used by the permutation. So randomly it's going to select four and make those things to none. That is a missing thing, right? So if you wanted to do that way, you have to use a permutation over here, right? So the permutation, if you're using it, I'm saying that tips dot index. So I'm going to take a random indexes, right? Only the four I want to make it. So if you want to make it only the four rows, the total bill to nans. So how can I make it this? I'm selecting four random indexes from this permutation that I was using. Then I have to come out from this bracket. Then I have to say only the four, right? So my bad, only the four, right? Good to go. Then I'm saying it here. So we have to select the column. So I'm saying that total underscore bill. Okay. Then what I can actually do here is in sense. Then over here, I can actually say the is equals to, my bad, is equals to np dot nav. Let me run this program right now. Now, if I'm saying the tips, now can you see this right now? The very first one is missing, right? Even you can actually select it, I mean to say this is anyway it's going to be happen very same way. Say 0 to 4, I selected it intentionally. So how come it's going to be 0 to 4 in sense the 5? 1, 2, 3, 4, 5. So that means you are actually selected the 5, the sequence of 5 in this data itself, because we already made the sample is this, right? I'm going to select only the sample of 10 rows from this data. Then I'm making it the first 5, because 0 to 4 in sense the indexes, that means 5 rows of data, and I'm making it to none. Yeah. So good to go, guys. All right. All right. So let's say, first of all, let me count it down. Non-missing values by sex. So we have males over here, we have females over here, right? Good to go. We have males and females. Based on this sex, that is a male or female, I wanted to count the non-missing values by non-missing values. So how can I do that in sense? Let's say the counting data is equals to anything that you can take it. The text dot, the group by sex column over here, right? Bad all the time. Right, the count. You know this. We already done this previously. Six. And look at this right now. Can you just count it? Can you just elaborate this thing? How can you understand it? First of all, how can we understand? So here, say the very 50th line, I'm running this again right now. Now we got total bell 3 and 3. Because if you just count it right now here, say
we
the
have
male,
3 male values and
yes, 3 male values
and 3 female values, which
3
are not
female
nan
values. Sorry?
in total.
Yeah.
3 male values, which are not nan in total, and three
This
female
is,
values.
this is, this is, and this,
Yeah.
this. And remaining all are not, so it's not linking up. The count is basically going to return for you this non-missing data count.
Yes.
Yeah.
Yes, sir.
Yes.
All right then. Let's say right now, let me come back down. No. So we already came to know that right now. Now let's calculate the grouped average and using the grouped average to fill in the missing values. What I'm going to do is right now in sense, now we're going to calculate a grouped average and use that grouped average to fill in the missing values. So we already found that missing values over here at the very first things. Yeah.
Yes. Yes.
And what I'm going to do right now, I'm going to find the average, right? I'm going to find the average that I'm going to use that grouped average to fill in missing values. So that is, I'm trying to going to fill something over this areas. So how can I do that? Right? How can I do that? Let's say right now here, I'm going to write a function, the def fill underscore na underscore main. Let's say I'm taking it the random, name for that. So this is something like returns the average of a given vector. So vector or series, right? Both are same. Don't ever get confused, guys. And I'm saying that here average is equals to the mean x dot mean. So it's simply going to calculate the mean for that particular column, right? So I'm returning this to the same function saying that, x dot, let's say, one moment. So what we can actually able to written here in sense, see, we have a fill any function where we can actually use that functions to fill in something, right? Isn't it so, guys?
Yes,
So I'm saying that x dot, right? X dot fill NA. So what I wanted to fill in sense, fill this average, right? So what I'm trying to say basically, in sense, this is X is a column, right? That means a vector. So what I'm trying to going to fill in the missing areas, in the sense, the fill in is going to be fill something in the missing areas. So I'm requesting to this fill in functions to fill this average rather than filling something else, right? So I'm going to call this somewhere in the situations. First of all, yeah. Now look at this. Now I just need to calculate a mean. I just need to calculate a mean total bill by sex. How can I do that? So let's say here I'm saying that calculate a mean of total underscore bill by sex column. Yeah. Then I'm saying here total bill group main. I'm taking very long name. Never mind for that. Tips dot. Tips dot. I wanted to group by sex column, right here. Then I'm going to say that here. So I want to calculate this total bill according to the sex column. I'm trying to looking for the total bill column. Then I'm going to use this transform. What is it? Transform, which is a function. So we said that we're going to use transform function, right? So the group by functions is mainly talking about aggregations, transformations, and filtrations. Now we're going to see the filtrations as well, just in a few minutes later. So I'm going to use right now the transform function. So I'm saying that here. It may be a bit confusing for you guys, but let me explain a bit, the step by step also. Don't worry. And I'm saying that fill underscore NA underscore main. So that means this thing. So let me highlight this thing first of all. Coming to the point here. So this thing is this, because we already written the function over here. So what are we trying to transfer in a sense? We're trying to transfer this total bill to the function called transform, right? Now it is going to invoke this particular function. Then it's trying to calculate the mean for that, right? Then you're trying to fill at the missing areas the average, not anything else. You're just trying to fill the average value for that, right? So let me clear all the diagrams over here. Let me close this, right? So let us see right now what's going to happen. And let me run this. And let me first of all create a new column in the same data. We have a tips of, let's say, I'm going to create a new column saying that fill total bill, right? So never mind if I'm taking very long names. Then total, so we already took this. I'm taking that total bill group main, yeah, and it's going to be over. Now if I'm calling this steps, so look at this data right now. Now we got filled the averages. If you can look at observe these values, previously those were none, isn't it so guys? These were none previously, the very first four. See this right now here, comparisons.
Yes, sir.
Now it got filled by the average by sex. Then if you can actually calculate the average for the main, the average for the sex male, this is the value. This is the value 20.37. If you can calculate the average for the female data in the 10 that we have sampled in the data, then you're going to get some other number. Then in that sense, that is different. But we have only the male data, right? So the male data, if you can just calculate this, let's say, if you can come out this, let's say, let me clear these diagrams first of all. All right. On this data I'm talking about. So see here right now here, say this, in the male data we have complete nans over here, right? Then we have left with these two, and this is a 1. We don't have any other males in the data. If you can take this value, this value, and this value also, and this value. Then how can you calculate an average first of all? See, we cannot calculate an average for the missing data. So it's definitely going to do, if I'm actually grouping by sex, then we have only the male's perfect data. The numerical data is only 3. For the male, we have 3, right? The male data we have 3. If you add 17.89 plus 28.44 plus and 14.78 divided by 3, because we got the count is 3. If you divide it by 3, you're definitely going to get this number. What number is that? What number you're going to get it? This 20.37. All right, you understand this?
Yes, sir.
So coming to the point over here, again, if you want to calculate the average for this female, you can actually take this 13, this, this one, 12.48 and 15.38. If you added them, divided by 3, you're going to get the average for that. So what basically we have done, what we have done actually in a sense, so we have filled the male average value at the missing data. We purposely made this missing data. In fact, we're trying to fill the mean values at the missing data. You can observe this, right?
Yes, sir.
Yes, guys.
Yes, sir.
Then if I'm trying to give you a clear picture over here, let's say in the print of, let's say, the tips of, let's say I'm going to access this sex column, then total bill, then there's fill and fill total bill, right? Is it correct, guys? Any mistakes? No, right?
No.
Yes.
You can observe this right now. 9. So 20.37, 20.37, right? It's got filled. So this is more and very, very important, guys. Somewhere in a situation in the real time when you're working with the real time data, you definitely face missing data. Without really having missing things in your data, that is not a perfect data. That might be a good data, but definitely the data which is coming from your database or somewhere, they are actually your project manager is giving you, definitely there is a missing data. If you wanted to delete them or if you want to fill something else rather than reducing the size of the data, right? It is more important than what you wanted to fill it. If you wanted to fill it exactly like the previous last known data or something like a latest value of the given data, then you can actually use this interpolate methodology, right? Like if we fill, B fill, right? We have already this discussion in the previous sessions. Yeah?
Yes, sir.
Yes, so we can use them. But if you want to have a specific thing that to be inserted at the filling side, you can actually use a fill any method, of course. There is no point. You can actually directly use that, instead of writing all these things, writing this, the function for finding a mean and filling up all these things in a very complex way of doing this, you can actually find the mean for this the valid male data and valid female data, right? That means a numerical things for the main, numerical data for the main, and numerical data for the female. You can separately calculate it. Then directly you can use this fill NA and say that particular male average data, you can fill it on the data. You can also use it in that way also. There is no question about it. I'm saying I'm trying to give you the new other ways to fill it. It's not something that I'm not using different methodologies. I'm trying to give you the new ways of writing things, right? You should not be confused somewhere in a situations if I use looking at different things later point of time. Yeah.
Yes.
Now we will be talking about this filter. What is this? This is like a filter. Filter. What is filter in sense? Let's say if you wanted to, now let's count it down first of all. I'll tell you the tips of. Let me take this like the complete data rather than taking the 10 sample data. I'm going to take the complete data right now. Let me take this as tips data, right? I don't think we have this tips data as a variable which we declared at the top. Now what I'm going to do, sns.load, again I'm trying to load the data set, okay, and tips, right, and the tips.head, bad. All right, so we got this, yeah. Now because I set the seed over there, it's actually giving in this way. Don't worry, right? So if you do not want to get this way, because the, all right, so this is something that the data. Now it's saying, yeah. All right then. So we got this. So let's say the tips underscore data dot. All right then. So what I'm trying to do, I'm trying to access the size column. Then I'm trying to counting the frequency of every size. Now we came to know that now there is the data which is talking about the size is the table size, like something that the two customers has visited and made a bill of there's $17, that is 16.99. The tip they have given is this. They're actually female, right? They're not smoker. The day is Sunday. The time is dinner. There is a 2. The table size is 2. 3 size and 3 size, 2 size, 4 size. We have so many sizes, right? Right. So I'm just trying to count it the size, the frequency. What is the total? We have 244. In that, the table size 2, the 2 customers has been. So there are about 156 data that we have it in this 244. The 3 size data, like we have 38. That is, we are trying to calculate the frequency counts of the size column. Right? Good to go? Right. Now, if you can ask you a question, it's not a question exactly, so I'm going to tell you, what I'm going to do. This particular output shows that table sizes of 156. This 156, 165, whatever it is. These 3. These exactly 3. The output shows the table size of 156 are infrequent, right? It is not something that recommend. I mean, it's you're not having so much of data for this 156. So depending on your needs, you may want to filter those data points out, right? Yes or no? So in this example, let's say we want each group to consist of 30 or more observations. If I put the condition as such, saying that I want to have at least 30 or more than 30, only that size, data should be have in my data, right? Let's say, how can I filter this data? So what I'm trying to do normally, in sense, I'm trying to eliminate this, the table size 5, 6, and 1, because the size, the frequency counts for this data is infrequent, right? Which we are not even having at least 30, or I'm not saying that exactly 30. I'm saying it. I'm going to grab the data which is at least to have 30 frequencies for the table size. So how can you do that in sense? Let me write down this here. The filter the data such that each group has more than 30 observations at least. Let's say, how can I write this? Let's say tips underscore filter, right, is equals to the tips dot, okay? The tips dot, what I have to do, guys? So saying that tips dot the group by, because I have to group it according to this size. So group by size, I'm saying it. Then we have a special function that you guys are eagerly waiting for that. What is that function? It's a lambda function. Lambda functions, we actually call it as it's an anonymous function, right? It's an anonymous function, the function which do not have any name for it, which do not have any name. So first of all, whenever we write a function, we write it this way, the function and function name, right? So no.
Yes or no?
So not bad. This way. And we're going to write some, data over here, right? But a lambda functions are anonymous functions. That means the functions which do not have any name for it. So, and let me write down the syntax. Let me complete this particular sentence and let me explain you what is this exactly and how we need to understand this lambda functions. Let me understand you very clearly. Don't worry about it. So I'm saying that I'm going to use this filter function because we're talking about the filtrations. I wanted to filter according to, see, I don't want this 1561 data because the frequency counts for this is very less. So I'm going to filtering my data according to this way because at least I want to have 30 observations in my data, right? 30 frequencies. So what I have to do in sense, so I'm taking the lambda. Understand, this is, I'm going to explain you, just wait for a moment. So I'm taking some variables here. So that means this variable is something like a argument, right? Then I'm saying that x of size, then I'm simply saying the count. You can actually write it in so many other ways, but I'm actually trying to give you the different ways of writing and programming. So please understand in that way the count which is greater than or equals to 30. Simple as this way. Then don't worry, let me explain you this. Then I'm running this first of all, then tips underscore filter, right? This is all right. And we do not have it listed, we have it, right? But what is the problem here that we have made? Please. So first of all, the data which is I'm taking it very top one that we have sampled only the 10, right? So I don't want that data be there. I want this data, this tips underscore data. So we're not taking this, the 10 sample data, we're talking only this data, this particular data, tips data, right? Then I'm running back the cell. I'm running back the cell. Okay, there's so many things, of course, and let me first of all give you the shape of this. Hold on a second. All right. Here. We got 231. So what I normally done here in sense, I'm trying to neglect the data. The frequency count is less than 30. That is the reason I set to 30 here, right? So that means the table size, wherever this table size is 5, wherever the table size is 6, wherever the table size is 1, which is having now, because the frequency counts for those table sizes are very less. So I set to the minimum 30 size, the frequencies. So those only retrieve. If we can, out of 244, we got 231. The remaining are very less, in fact. Right, guys? If you want to say, let's say the print of the tips underscore filter, let's say the size, but it's not, size, it's correct only. The dot, the value counts. See, right now you're going to understand it. We only got 2, 3, 4 sizes, right, guys? These are the table sizes. 2 table size, we have 156 data. 3 table size, we got 38 data. The 4 table size is this. Because we set to the, now there's at least 30, it is only retrieving more than 31, right? So understand in that way. And coming to the point, you may be, you're wondering about this. What is this lambda? How we need to understand this? Yeah. So let us talk about this for a moment. Now, if I talk about the lambda function, so I wanted to make you guys understand this. In Python, anonymous function is a function that is defined without a name. So that anonymous function, we call it as a lambda function, in fact. So let us come to the discussions. So how we need to understand in sense that lambda is a keyword. I'm sorry, no, let's come back to here. So let me say the lambda is a keyword. You need to write, it's going to take an arguments, right? Then this side, after colon, anything that you write, this must be an expression. So the arguments, an expression. So coming to the point, if I tell you, so here, lambda functions can have any number of arguments. It doesn't matter. You can put a comma there and you can write it. It's not an issue, right, guys?
Yes, sir.
But only one expression, right? Only one expression. but you can have n number of arguments, but only one expressions. Let's say, you know, this a function can expect any number of arguments. Yes or no?
Yes, sir.
Based on the parameter size that you have to pass those many arguments to it. Isn't it so?
Yes, sir.
Well and good. So in the same way, it can actually have a number of arguments. It can have n number of arguments. It can actually take only one expression. We need to understand. So how we need to understand this? It's more important, right? So let's say I'm taking that here, the double, or you can take anything. The double is equals to lambda. I'm taking it, right? Then I'm saying that x, I'm putting a column there, right? X in, I'm squaring up this. Now, if I call this, let's say, first of all, if you, okay, let me call this first of all. Then if I say here, enter, and if I say the double, it's like a function. So I'm passing some number here, see, right? Now see what's going to happen. It's squaring up. How? Now this is similar to that you actually define, the double, saying that this is expecting x, and x, like this by x into 2. This is same way. Then if I call this double function, then you're trying to pass 2, right? It is squaring up. Yes, in the same way, but if you use a lambda function, there is a function, but it is not visible, right? It is an anonymous functions are, something like you cannot see a function, but there is a function, but you actually declare with the lambda. The lambda of x, this is an argument, right? Now, this 2, you are passing 2 over here. The 2 is getting squared up and it is returning. It is returning to the result to the anonymous function. It is overall returning that written statement is 4. That you're trying to print that 4 over here. Good to go, guys?
Yes, sir.
In the same way, if you want to understand this particular statement, it's simply a grouping by size. According to the size, you're grouping all the data of the keeps data, right? Then you're trying to pass a group by group. The 2, 1, you're trying to pass it. The 2, 1, you're trying to pass it and checking if it is greater than 30. Yes, it's definitely greater than 30, right? Then it's 156, then it's going to be considered. Then you're checking that the 3 table size, then the frequencies we have is 38. Okay, definitely it is also considerable because it's more than 30, right? Then it's simply, this is an expression. It is going to return whether it is true or false. Yes, if it is true, you're going to get that data because we are actually getting counts of the days. Say this, right? The 37 is accepted. But these are the things, it's 544. For the table size is 561. These are infrequent. That is the reason it's not getting counted because it's less than 30. But we are only looking out for the greater than 30. We only get that thing. Yeah. Now there is a function here. There is a function here. You need to understand the filter is also going to take a function only. But where is the function? There is a function. The lambda is an anonymous function. The function which is taking one parameter, right? That is the reason you are passing only one at a time, right? Then it's trying to calculate whether it is acceptable or not. If it is acceptable, it's returning that, and you're going to be considered that thing.